It's always a joy to have Jeff with us, and Jeff Welton from Nautel. And our discussion today is about spring cleaning, maybe a little more of the RF end of it than just the getting out there and whacking the weeds in the field and checking your fences. And I do have a checklist for that we're going to post here pretty soon. And yet there are things to do in the plant itself that we should take the time to do. And last month, Jeff started with the idea of having a current set of transmitter readings. Oddly enough, for some people, that's the one set of readings they get a year. And don't recommend that. Jeff doesn't recommend that. But that's a way in which to know at least where something is. And so where do we go from there, Jeff?
Well, and I mean, the readings are critical. And the funny thing is, while you were talking, or while we were talking in the preamble, my VPN connection died and has not allowed itself to reestablish. So I'm going to wing it for a lot of this. But that wasn't my first choice. It was just what I happened to be doing when I logged in to begin with. Anyway, so yeah, if you don't have a set of meter readings, and I argue the best time to take a set of meter readings is you do the set when you install the transmitter. Now, a lot of us don't have the luxury of installing the transmitter. It's been there 10, 20, 30 years before we got there. But get a set of meter readings of everything, anything you can measure that has a meter, because then you've got a benchmark. And then, yeah, set a regular. Now, and I'm like the FCC on this. I'm not going to say do it every hour, do it every day, do it every week, do it every month. I'm going to say as often as you need to for your particular situation, um, which, depending on the transmitter, if I've got a tube box, for example, where I know that the filament voltage is going to change as the tube ages or current or whatever, then I may make those readings a weekly requirement. And the cool thing then becomes how we can use the technology. You don't necessarily have to go there to do it for anything that you've got a physical meter on the front screen. You could have a PTZ camera on the in the side of the room and just aim it over and zoom in on the meters to take your readings. It still requires some intervention, but if you're not getting regular meter readings, you don't know when stuff's starting to drift. And, depending on load or ground system or tube age or all kinds of variables, that the slow changes are the ones that tend to be the surprise.
Funny for you to be talking about tubes there, Mr.
Hey, there's still a lot of them out there. And I mean, it makes no sense not to tell folks how to get the best they can out of them.
That's true. Back in the old days, before you guys took over, at least at several of the sites that I have been caring for, one of the first things you do is you go in there, take a set of meter readings, and then what? Dip your plate current.
Or grid current, depending. But yeah. I mean, you tweak, rock the tuning a little bit to make sure everything's still optimal and that it hasn't drifted off too far. And you again, you had a reference, you had a benchmark to work against. So you knew after it got to this point, it's like time to start looking at ordering a new tube. Nowadays, seems like the time to order a new tube is typically about the time the flames have come out of the old one.
That's about the size of it. Now, let's start here with the transmitter. Now, what are the things that would cause a transmitter to change the load or the current? I want to say voltage, but that isn't really with the modern solid state stuff. That isn't really a major deal. It's the current. But what would be the thing that would change over a period of the winter time, let's say?
Well, they all tie together in a way. I mean, because E equals I times R. So, if you change the volts and don't change the R, then the current's going to change, or vice versa. But load wise, one of the biggest things I run into is ground connections getting loose or getting oxidized. And when you do that, you can see a resistance change. It won't necessarily show up as reflected power because reflectometers tend to be more focused on phase differences. But if you run into that situation, it can impact both your voltage and your current. For example, if ground resistance on one of our AMs goes high, say you go to 60 ohms plus J0 instead of 50, then you're going to see your PA volts go up for any specific output power. Correspondingly, your current will tend to go down a little bit. So again, you'll see a change. You'll know you've got something going on.
What would cause these changes to happen?
Uh, well, again, oxidation in a ground connection would be one great example. But if you don't have really good ground rods established or a good network of ground rods, just having the ground moisture level go down. I've got one site in Tennessee where we've measured the load impedance at the output of the transmitter, shifting from 40 plus J5 to 60 minus J5 over the course of a year cycle, just because of the ground drying out and getting wetter.
That's quite a change.
That's an extreme. So, I don't expect to see that at most. Although I've got a couple of tidal sites that'll see that level of change twice a day, every day.
Yes, if you've ridden the Bay of Fundy. Um,
Not just there. I mean, West Coast. I know East Coast, like over where Grady is. I'm sure he's got a few marsh type sites that shift a little bit from hour to hour.
the
And
other
again, yeah, 20 ohms is a pretty significant change, but it does happen.
Well, again, it would depend largely upon how good the main ground is. And as Tom has told us a few times, the technology of grounding has changed. And most people don't realize that what their ground is sometimes quite far from ground.
Yeah, I mean, the technology's changed somewhat. The theory has not changed a whole lot. I mean, a good single point ground is still a good single point ground. How you get there has evolved a lot. And yeah, I mean, whether you use carbon fill or carbon backfill, or whether you use chem rods, I mean, up here, my running joke is if you want a ground system up here where bedrock is a couple of feet below the surface of the topsoil or above it sometimes, you may need a stick of dynamite. You're not going to get an actual ground unless you can get into the ocean.
Oh boy.
So yeah, you sometimes you may end up. I had a mountain site in Arkansas. They ended up drilling a well and steel casing a well. So
We
it'll vary depending on where you are.
we did one about 20 miles south of Tucson up on a mountain, a rock, and the tower guy, he drilled, I don't know, three, 4 dozen uh, holes to put ground rods in and make a quasi ground. But you get to these places where it's just a rock. What do you do?
Hmm. Yep. And I mean, a lot of that, you just put down a network of copper and hope for the best. Well, you hope for the best to say you'll drill rods where you can, or drill a well, or tie it to, something that is going into the water table. But yeah, it's going to be somewhat situational. Here on the East Coast, we don't have to go that far down to hit the water table usually. So it can be a little bit easier. But again, there's going to be some drilling involved usually in our
Sure. And there
case.
there are some stations that will actually water their ground system during dry season to try to even things out, especially if you have a what we used to call a critical DA that would wander, unfortunately. Well, okay, we've got the ground system, and it's important as part of the spring routine, I think, to go out and walk the whole field and see how much of the ground system is
Still there.
still there. Yes, because vandals will come in and they'll try to make 20 cents on your $10,000 ground system. Or the other thing would be some of the grounds become exposed over a period of time.
Yeah, or up here again. I mean we don't have a lot of AMs left in this part of the world. Most of them have flipped to AM. But the biggest challenge was that, of course, ground radios typically are 6 to 8 inches below grade, or a foot maybe. Our frost line is 3 feet down.
Mhm.
So a lot of times we'll have rocks just tearing ground systems apart as they get chucked up in frost heaves.
I've heard
So
I've heard people say they use gorilla snot to discourage vandals.
Use which?
Gorilla Snot.
What is that?
It's a sticky thing, almost like Gorilla Glue,
Ah,
but
okay.
it's more, I don't know, what would you call it? Like Play-Doh or something, but once it forms around the ground system, it's really hard to get off the copper or to get the copper out of the ground.
I've had a lot of guys tell me that they use roofing tar for the same reason. It kills the resale value of the copper and also makes it a lot less visible.
Yeah, yeah. So now we got the ground system, and let's say we've inspected it. The ground radials are all there. We took our field intensity meter and we measured the fact that there's still 120 radials or thereabouts. And we know that the ground system is, well, we depends. I guess there are some good ground meters that you can use to identify really how close you are to a ground. But then let's walk through the system. Next thing you have, obviously, is the transmitter. You have the output filter, you have the coax, you have the antenna. All these things could create problems in terms of efficiency or uh, reduction of, uh, I want to say reduction, but not actually bouncing it back, VISWAR, where the
Mhm.
transmitter is operating in such a way that it gets hot for no real good reason.
Well, and not just that. And I am trying to find a picture that I just got the other day. But the other thing, too, is that especially with AMs where you may have a daytime power and a nighttime power, and you're constantly twice a day shifting between high power and low power, or in a daytimer, high power and off. You've got a lot of thermal cycling, heating and cooling. And I mean, everybody knows that a light bulb is under more stress as it's turned on or off, not while it's actually running or not running. So, the same thing's true with semiconductors. So they're under a lot more stress that way. There's a lot more heating and cooling in the mechanical connections. So this is where you want to go through, like in an AM, you go through the output filter and check the nuts and bolts that are holding the cast mica caps or the vacuum variables or whatever together. Check the hardware. And I tell people that it should be, I mean, we recommend once a year, but at least once every 2 years, you should schedule some downtime to go through and just make sure everything's still snug,
Downtime meaning
off air
the
or on
back of the
backup.
transmitter.
Yeah, I'm young enough and old enough that I don't crawl through transmitters while they're turned on.
Thank
Yeah,
you.
no, I want to shut the thing off and be able to physically get in there with a wrench and just make sure that those things are snug.
And you don't want to use a blower or compressed air.
My preference is vacuum. And especially in tube transmitters, my theory is, especially in the HV sections, that if you're moving dust with compressed air, you might be moving it from a place where it wasn't causing an arc to a place where it could. So, yeah, I'd rather remove it totally with a vacuum.
How often do you get folks telling you that the output network in one of your transmitters has gone bad?
That's one of the things I was trying to get load, and I'm going to guess that my network connection here at the house is currently underwater because both my VPN and my Facebook are arguing with me. So we'll hope that we stay connected here. But I've got one right now in Ontario. I would guess we probably get that call once every couple of months, give or take, out of about 15,000 customers, give or around about. So yeah, it's regular, it's periodic but regular.
Is there a
Whether
common thread?
typically it's going to be a shunt cap, but again, no, not really a common thread. It's like I said, it's once or twice a month, or a couple of times, or every couple of months. So it's not something that happens often enough that you could really tell. I would guess that it's pretty evenly split between known lightning events and it was just running and then it blew up where, maybe a piece of hardware worked loose or maybe a fan had failed and the temperature alarm didn't get there before the capacitor let the smoke out. So stuff like that. But again, that is a little bit of guesswork. And, like I said in a conversation this morning, the plural of anecdote is not data.
You just said the magic word, by the way, temperature.
Yeah.
I've
Well,
seen I've seen, and I'm sure you have too. I've seen transmitters that you can't touch the transmitter because it's so hot.
right. And I mean, some of it is different. And this is coming knowing the equipment, like different manufacturers use different airflow layouts. And they'll use, for better or worse, different mechanical layouts within the gear. And it may, in some cases, end up causing some back pressure. So if you don't put some positive pressure at the air intake to force the air through it, then it's natively going to run hotter than a different box that's designed in a different way. I'm trying to be super tactful here because I don't want to call anybody out. I mean, things are what they are. But yeah, so knowing your transmitter, like I said last time, ours the air intakes are on the big FMs are front and rear. So knowing that, you force air in both sides, you minimize the back pressure, you maintain better cooling throughout the gear, and the side bonus is the fans live a lot longer because they're not fighting the back pressure.
And you hope that the vandals don't hurt your AC conditioners.
Well, that's
Also keeps it cleaner inside.
positive pressure. Absolutely does. Yeah, if you can
Speaking of
positive pressure.
positive pressure, now the
Yeah.
next step. After you've gone there at midnight to open the back of the transmitter and to work on it, although some of them you don't actually have to open the transmitter to do this, change the filter.
Yep.
You
And again, the
run
schedule
down to
on
Home
that is
Depot. Yeah,
and I
whatever.
say this schedule, well, two things. Number one, the filter may or may not be available from Home Depot. So, I mean, some of ours are, some are not. So pay attention to that. Keep a spare stock at the site. Number two, build a schedule based on your own environment. Because, like Ken said, if you've got a clean air room with positive pressure, your transmitter filters might get swapped out every 2 or 3 years. If you are just sucking outside air in through an intake fan or using an exhaust fan and dragging the air in through every crack and crevice, especially in cottonwood season, you might swap your air filters every week. So it's very much going to vary by the site, but make sure that you have a stock. I mean, here at the house, I used forced air convection heating, forced air furnace. And I swap my air filters out every 3 months in the summer because we use the furnace blower to cool the house then because we blow the cool basement air upstairs. And that's our version of air conditioning in the Great White North, by the way. But then in the wintertime, I change the filters every month. And it'll, yeah, so know your specific cycle and make sure you've got air filters on hand.
Yeah, yeah, that's important. And of course, the hard thing is you want to make sure you buy the right air filter to begin with.
I'm glad you brought that up. It's like we were thinking the same thing. I just took a call from a guy 2 days ago who had a VX1.5, brand new box, that was not able to make above 400 watts. It was kicking off with a PA overtemp alarm. And what it turned out was that his other engineer used some filter media that he had for a TV transmitter that apparently was a whole lot denser and didn't let nearly as much air through. So temperature in the transmitter get quite a bit warmer. Replace that with the proper density based on our design, and everything went right back to happy, and he's making 1600 watts again. So absolutely make sure you're using now I understand, like we use American Air Filter MERV 8 16 by, I forget the size, 15 by 24, I think, an oddball size in a lot of our boxes, 2 inch thick. Any MERV 8 filter will pretty much do the job as long as it's got the physical size. I don't care who made it. But yeah, like I had one guy that swapped his MERV 8s for MERV 11s. Well, that means a much higher density, smaller pore size, more air restriction, less cooling. So you're taking a calculated risk when you do that.
Now, if you get past the air filters and the output network of the transmitter, next thing you're dealing with is the coax, filters, and your antenna.
Mm-hmm.
Now, the filters, of course, in most cases, will be to filter out other stations so that you don't have intermod products and things like that. And they can cause problems.
They can. It's pretty rare. I mean, especially for FM, you're talking chunks of insulators, whether it's phenolic or Teflon or whatever, and brass or aluminum, making the length of aluminum will be an inductor or a capacitor, depending on what you put it beside and how long it is. So failures in those, except in the instance when you get an overvoltage situation, like from a lightning strike, they're pretty rare.
Mm-hmm.
I mean, typically, even if you have an exciter that decides to broadcast on all the frequency and goes off frequency, then the transmitter's SWR protection will detect the mismatch between that and the filter that's tuned for the frequency and trip you off long before you blow up the filter. So, really rare to see those fail. What you can see is if you've got circulators to notch out something specific, or in a high level HD situation, or if you've got a branch combiner or a channel combiner with cooling fans on it, you can see the fans fail. So that's something else to pay attention to. Anything mechanical that anything that moves normally will at some point stop moving. And Dave's got a good comment here as to post where you got the filter and what's the product number. And I don't know about price; that's pretty variable, but absolutely having a source for that, if it ever does fail, is going to be pretty critical.
That's part of really what you need to have at a transmitter site in general. You want to have all your transmitter serial numbers and
Yep.
other data that tech support's going to ask for when they call. If you're dealing with certain transmitters, there may be 10 generations of transmitters out there, and you better know which ones you have.
Yep.
Then you want to have all the phone numbers for the utilities so that if you lose power, you know whom to call at the power company and what to tell them so they know where you are. And the
Right.
same thing goes with your air conditioning repair, your generator maintenance folks. All these things ought to be in a little booklet or a paper on the wall, all the
Right.
things that you need to have.
I mean, for us at the studios at our station, there's a whiteboard with one corner that's been lacquered over, and in that corner, it's got the contacts for me, for the GM and studio engineer, and just yeah, some half a dozen in case of this, call this person type scenarios, and it's lacquered over so it's a little more permanent. Daryl had made a good comment too about the vacuum, about the static electricity and electronics, and that's a really good point. And I meant to mention that. The trick to that is if you take a piece of zip cord or just a single conductor, 10, 12, 14 gauge, whatever, strip about 6 inches off the end and wrap it around the end of your vacuum hose, tape it on there really good so you got a good connection, and then take the other end of that wire and bolt it to the rack of the chassis of whatever you're vacuuming. And, I like to put a lug on it just because I'm lazy and it's less work. But that'll give you a whole lot better because you'll create in static two ways. Number one, you're moving dust across components. Well, you can't control that, but that's typically smaller static. The plastic in the hose itself is where you tend to have an issue. So having a ground connection to that will minimize the amount of charge it builds up.
Okay, now we're past the filters and we're into the coax and the antenna, and these areas can create problems, as you said before, with a lightning strike. That would certainly cause the Viswar to rise on AM or FM, or
Yeah.
if you had a blown cap in an ATU.
Or if you've got a pressure relief on a pressurized antenna that is welded open or stuck open, like one particular manufacturer had an issue with a bunch of years ago. Uh, or if you've got a bad seal and you're getting some moisture ingress. So that's this is where paying attention to your dehydrator or your whatever you're using to maintain air pressure in a pressurized line is critical. I ran into a site in West Virginia last summer where walked in and transmitter had a bunch of failures. Well, the grounding was less than stellar, to put it bluntly. But the turned out that the dehydrator was unplugged too, and because I glanced up and saw it was at zero, and then saw the lights were off, walked around back, saw the power cord just laying there, so I plugged it in, and it came up, started running, and we watch it, and it's 2 psi, 3 psi, 5 psi, 6 psi, and while it's climbing, I'm looking up the specs on the thanks to Mother Google, and discover that that particular dehydrator was rated for or was calibrated for 5 psi from the factory. So by the time we got to 7, it's like you might want to unplug that. So we unplug it, and it was holding pressure, but the problem was that the dehydrator wasn't shutting off, so the internal pressure switch was failed. So yeah, again, those are the kind of things, it's the short term fix was to unplug it, but that radio station temporary is a thing.
Yeah,
And
unfortunately, that's true. Well, let's invite anyone who would like to join our discussion, and perhaps you have a tip of transmitter system maintenance that you'd like to share with us that Jeff and I haven't mentioned here. Unfortunately, if you are among the dozen and a half over on the YouTube Live, I don't have a chat box over there this week, and all I see are other videos, and no one has actually explained to me why one week I've got a chat box and this week I don't. But you could email me, and if I see it, Barry@oldradio.com, we'll bring it up, or we'll talk to the folks that are here on the Zoom side. And if you want to join us by pressing your space bar, alternate A, to open your microphone, or raise your hand, let us know that you're wanting to contribute. That would be great, because Jeff and I don't know everything. Jeff knows almost everything, and I know a little.
no, I do not. I do not even pretend to know almost everything. The only thing I know is the more I learn, the more I realize how much I don't know.
Yeah.
So no, but this is where it's really cool to have people that do know more, and I see half a dozen names in here that I know more than I do about a whole bunch of topics.
Hey, Jeff, I do have a question.
Yeah.
I'm Daryl. I sent in a comment about static electricity. You
Yeah.
talking about the wire. Say you vacuum out a computer. The main thing you want to be is grounded, right?
Right.
Okay.
Now,
Well,
and so I'm going to take that a little step further, because and using my zip cord on the vacuum hose as an example, I would ground that to the computer chassis, but I'd hardwire the computer chassis to a ground as well, because I'm not going to rely on the ground wire and the electrical cable. Now that becomes a challenge. And if you look at Nautel as an example, I mean, our facility has evolved from one building to 7 buildings over the course of 55 years. Some of the electrical, most of it's been upgraded, but some areas it's still using old cotton wrap 2-conductor wire where the ground is marginal, if existing at all. So any area that we're working on static stuff has a dedicated ground point in that room. So yeah, make sure you ground everything.
what size wire again was it you use for a good ground wire?
For static, it's not really critical, because we're talking just decoupling a DC charge. I mean, you don't want anything really, really, really small gauge, because it presents quite a bit of resistance per foot. But 14 gauge, 12 gauge, just regular zip cord will usually do the trick for stuff like that.
Okay, thank you.
Sure.
Anyone else like to share with us a question or something that you did, something you found at your site?
I have a question. Is there ever a use for conductive sprays on plastic pieces such as vacuum cleaner hoses?
I don't have an issue with them as at least a temporary use. I mean, especially if you were attaching a ground wire, having a conductive spray would give you a better connection. Um, I see a lot of folks that like the anti-static spray, and all you're doing really is adding to the moisture content to help it from not building up a charge. The downside to a lot of that stuff is over the long term, it tends to get sticky. So at that point, it becomes a dirt magnet, and I'm not a big fan of that. But yeah, not again in certain scenarios. NAB next week, I can guarantee you, every morning, everybody that walks into our booth for the staff will be giving themselves a couple of squirts of static guard to make sure A, that we don't fry the transmitters, and B, that we don't zap ourselves every time we lean against a rack.
Anybody use Snuggles?
Dryer sheets work well. Yeah, no, I mean, the fabric softener is the same. But again, you get to the situation or run into the situation where it does tend to get a little sticky over the long haul, I found. Now, I guess if it's the pants I'm wearing at NAB, it won't be a problem. They'll go through the laundry when I get home. But if I was like carpet in a computer room, that might be an issue. Trying to see who else is out here I can pick on. Oh, Mary, hey, the local auction site I was on had a couple of sets of red high-heeled pumps on sale last week. Totally non-related to anything, but I just happened to notice them and thought of you.
Anyone else care to share a part of their spring cleaning routine that we haven't covered yet?
Oh, I will. One more too. Power supplies. Oh, please, 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 please. Whether, especially on the big iron, go through and check the power supply hardware on occasion, and ground it first before you touch it.
I was just about to mention the stick.
Yeah. Well, and that comes back to working in the HV section of a tube rig. But I had a guy call me once from Virginia, and he was working on a 5 kilowatt tube AM. Forget which one. Might have been BC5A. I don't remember. But he'd gone through. He'd shut it down. He'd applied the grounding stick liberally throughout the whole thing. And as we're talking, he's got me on the phone while he's checking stuff. And I'm not sure why, except I just think he wanted somebody else on the other end of the phone in case. And all of a sudden I hear an ouch and a string of cuss words. And what had happened was that the problem with the transmitter was a wire that was broken off at a lug. So when he grounded the capacitor in question, he discharged the capacitor just fine, but the wire that was broken loose was still pretty hot. And when he hit it, he found out. So, yeah, use the lug, but what do they say? Trust but verify.
Ron Ziegler, Mark, you know who I'm talking about. Ron once told me about a transmitter he went in to work on, and he disconnected the power and pulled down the breaker, put his hands in there, and promptly got zapped because somehow a previous engineer had rigged the wire so that it was being fed from two different directions, one for the base transmitter and one for the exciter.
Not just that. I mean, if you look at our old 50 kilowatts, you had two 480 or 600 volt AC connections, one for each PA power supply. But then you had a separate 120 volt feed for the exciter and the relay logic. And a lot of folks would switch off the two big breakers and then go grab the exciter, which had exposed 120 underneath it. And yeah, you touch it and it's not going to typically, unless you're standing in a puddle, not going to kill you, but it'll get your attention. that kind of brought me back to something else, and I'm having a brain fart on it. So you keep talking, and I'll think about it in a moment.
Okay. I'm going to expand the thought from spring cleaning to regular maintenance. Now, some of you are going to tell me that because of the number of stations that you are tasked with, or the distance, or whatever, getting to each of these transmitter sites every 6 months is a chore. But what do you think about having a routine where you visit the transmitter at least once a month? Anyone have thoughts about that?
I always did it once a week.
And I lean more toward the once a week to once a month. Now, having said that, I live 10 miles as the crow flies from my transmitter, and I haven't been there. Well, no, I was there a month ago because we were doing some work on it. But we can go several months between site visits. We rely a lot on remote connections. We've got for everything, the transmitter, everything on that is IP accessible, both transmitters. And then the physical things, we've got again, a Wise PTZ camera in the corner of the building that I can zoom in and physically look at to make sure the fan's going and things like that.
That's a blessing and a curse having all that IP connection. It's a blessing because you can pop in and look a good part of the time. It's a curse because if that goes down, now you're really blind.
Yep. Well, it is, but I mean, by the same token, if you've got it set up right, then when it goes down, you'll get notified of the connection loss as well. And so you know you've got something else that needs to be dealt with. For us, since we feed our audio over the same dark fiber, it's pretty obvious because if that remote connection goes down, we lost audio, and somebody's already moving. Scott's got a good comment here about doing cleaning in the fall, and again, like I said, it's situational based on your environment. But yeah, if you're further north and you get a lot of snow, you don't tend to get as much dirt building up in the wintertime as you do during the summertime. And you may, for us in the winter, we close all the louvers, so we're just circulating the room air. And yeah, we don't get a whole lot of crud building up over the winter. And then John's got the good comment on the one hand, and I'm going to augment that a little. And let's see while I'm thinking about it if I can find them.
I think
But
the very second issue of Radio Guide that I did, we had a front page picture of the good friend with a stick in one hand and his other hand in his pocket.
right, and beyond that is EH rated footwear. And I mean, so EH is electrohazard rated. That's the US designation. But it's hard to make an argument not to have EH rated footwear anymore. And I mean, like I'm searching Walmart right now. I went to EH footwear. I've got men's EH rated work boots for $109. I've got women's sneakers for 88. You know, there's all kinds of options out there for in the $100 range. And again, this is Walmart. Any shoe store will sell EH rated footwear. And so the theory of EH rated footwear is that if you put 18,000 volts from insole to outsole, it won't pass more than a milliamp of current. So it's basically a big honking resistor, and it will keep you alive when you do something stupid. And I'm living proof of that because I do something stupid more than I should some days.
Well, I had to check and see what Bucky Dornster wore, so I made sure I had the right one.
There you go. But yeah, so I'd say I'm looking on Nautel or on Walmart.com, and I'm seeing a lot of options in the under $100 range. So, you know, you've got some choices. But that's something that I won't walk onto a transmitter site without EH rated footwear on as a rule. Not for a big box anyway. Little ones, I don't worry as much, but even so, 240 volts, if you're standing in a puddle with wet feet, that could be a problem.
Well, you have to go in and out of so many different places, and you never know what you're going to find. So it's good to be prepared, have them on
Yep.
your feet.
Right. And I mean, typically I try not to wear them too much out in the dirt. I'll usually carry them and put them on if I'm going to be working at a site a long time. But, you can get, here's a pair of EH rated, here, I'll do a screen share just to show what I'm talking about. If I can remember how to do that. I've got to view differently. Full screen, that should work. Share screen and screen 2, share. There, so here's an example. And again, this is just walmart.com. So, and I even went to the US base, but just a prime example, they're carbon toe. Typically, you won't find steel-toed safety shoes with an EH rating because, well, steel kind of does the opposite of what we're trying to accomplish here. But those are the kind of things that will save your bacon if you get across the big power supply just by accident, or somebody said it was turned off and it really wasn't, or somebody did turn it off, but one phase of the breaker was welded short. How many people have encountered that one before? Yeah, Jerry's got his hand up, and that's always a surprise. The first time you shut the breaker off and go in with your meter and measure and discover one phase has still got 240 volts on it.
Not exactly the kind of surprise you want.
Like I said, trust but verify. I'll shut the breaker off. I'm still going to measure.
Well, that's the most important thing to do.
Yeah. And whether you do it with, let's see, it's gone again. I've got one of those little BGS came out a bunch of years ago, the little proximity volt alerts. I think you might have had them as one of the giveaways at one of the BDR lunches one year.
Yep. Still got a few of them here.
And then you had that little multimeter one year. I still use that. But yeah, I mean, absolutely. Just because you shut it off doesn't mean it is off. So always double check.
Yeah, that proximity voltage tester is really a lifesaver in a real way many times.
Yeah. And David makes the comment, never believe someone else has turned the breaker off, do it yourself. So over and above the double checking, that's a really good point. I've been at Nautel almost 34 years now. We've had 3 injury accidents related to AC, and in every single case, every single one of them was somebody was told that a breaker was off that wasn't. In one case, it happened in our test room where the supervisor told the tech the breaker was off, but the one he'd shut off was not the one that was connected to the equipment in question.
Whoops.
So again, now we have a pretty strict trust but verify. So you don't stick your hands in anything until you've used a proximity tester and a meter. You can get the HVAC meters where you just connect one lead to ground. So all you're holding in your hand is a meter with one probe sticking out, and you touch that to the things you want to worry about.
I've heard of some using the lockout system.
Yep. Big fan of that. You can get lockout kits from Home Depot for under $100. And now I'm on a roll here.
Requirement most places these days.
Yep. And it's a really good idea for a couple of reasons. And the big one that I go with is as we get busier and busier and don't have as many people doing the things, then it becomes more important to sometimes just sort of slow down and think about where you're at. And there's an example of what's available at homedepot.com for lockout kits. But, and I mean, it could be as simple as a single shackle to let's see, they had at one point, there we go, the full-blown lockout stations. What's that, Barry?
Didn't bring it up on the screen.
Oh, I forgot to actually click the share button. There we go. It's a problem when you got too many monitors and not enough brain cells. But yeah, so you can get a full-blown lockout station for under $100, or you can get the various pieces to make your own lockouts as you need to. And these things, the thing I tell people is that I'll tend to, if I'm at our site, I'll tend to use it just working alone. I mean, there's nobody else there to turn the breaker on, but it's just the thing that reminds me, did I put the interlock back that I had to bypass? Did I reconnect this? Did I remove that short from the AC? You know, just run through your little mental checklist before you pull the lock out and apply the power again.
Very good. Okay.
During this moment of silence, I will say that when we were talking earlier about shorting things out in transmitters, now that most transmitters don't have, quote, high voltage in them anymore, a lot of transmitters don't ship with anything to do that work of shorting things out. So I've been through several 50 kilowatt transmitters that could no longer be made to run efficiently, and nobody wants to buy them. And I've gotten all of the Jesus sticks out of them, and I've moved them and put them at most of my transmitter sites where there were not such things before, just so I have them.
Yep. And in a pinch, if you're at a site where you don't have one available, a set of booster cables, a roll of duct tape, and a wooden broom handle. You can make a grounding stick. So yeah, I mean, absolutely.
I've seen them use the jumper cables at the bowl gap.
Yep. Well, and there's something else that a lot of folks, I mean, and I think I've told this story before here, but I had a situation in Paraguay a few years ago where a guy was working on, it was a 200 kilowatt of ours, might have been 100. I'll get the power levels backwards, but for the purpose of the story, it doesn't matter. Anyway, he had shut the transmitter off, and our high power rigs, the really big ones, have keyed interlock systems that force you to ground the antenna connection at the transmitter output in order to get the key for the AC box. So you physically have to ground but you need the key out of the AC box to unlock the lock box that gets you at all the keys to get into the transmitter cabinets. So you can't get into the transmitter. So he had shut the transmitter down. He had grounded it. He had done everything right. Then he went out to the tower, quarter wavelength away, touched the base of the tower, and got second and third degree burns because the 200 kilowatt or 100 kilowatt station a couple of miles away was still on the air, and antennas receive as well as they transmit. Actually, some people will argue that they receive better than they transmit. So anyway, point being that the RS going both ways. Sorry, Grady, I saw you unmute. What's up?
I was just going to tell my quick story that once the output stage in my Delta RG3 box, which is that receiver detector thing that you use with their bridge, I had the output stage in that burn up because I was hooking up to a tower in a marsh about 6 miles across saltwater from WBZ FM. And with nothing connected, there was like 30 volts of 1030 across that base insulator.
Yep. I blew the front end out of a Potomac Instruments walking into a site and turning it on before I put the switch to 10 volts per meter. And turns out that 50 kilowatts of AM is a lot of volts per meter at about a couple of 100 feet from the main tower. It made this squealing sound and wrapped the needle around the pin and never did work again. So you learn most of your best stories or best experiences come from the things you survive that cause something to blow catastrophically.
Yeah, on the incident that I wrote about where I probably got my life saved by keeping one hand in my pocket, I'm not in the habit of behaving foolishly around transmitters, but this was a Continental 816R series that had the tube drivers where you sometimes had to tweak the cathode settings while it was operating. I never did like that design. I'm glad we retired that transmitter.
Were those the ones where you had to reach right, like actually inside over the supply to get to the adjustment?
Yep, your hand was less than 12 inches away from the terminal posts of a 15 kV capacitor.
That'll get your attention.
And on the incident I wrote about, there was a heat sink on top of the tube driver stage where there were a couple of transistors and other components. And the incident I wrote about, on one of those occasions, one of those, the transistors had shorted its case to ground, or the case was shorted. And I later when I reconstructed things later, it was putting about 300 or so volts of DC current on one of those transistor cases, and I brushed it. But because I had the one hand in my pocket, that 300 volts DC pretty much stayed, or didn't pass through me as much.
I've told this story maybe a year ago here, but for those of you who weren't here or maybe don't remember it, Dana Popolo wouldn't be here today on the surface of the earth if he hadn't been really, really lucky one night. He was working on an RCA ampliphase with me in northern Rhode Island, and we had killed the power, and we thought the power was off. All the lights on the front of the transmitter were off, and he opened the front door of the transmitter and reached in to start to disconnect one of the PA tubes, and he hit the grid ring with his fingers, and he felt something, and he pulled out and grabbed the stick, and when he hit the plate of that tube, he drew a 1-inch arc. It turns out that the plate, the high voltage power supply primary disconnect relay was a thing that lifted fingers up into a big set of contacts against gravity. But when you released it, it just assumed that gravity was going to pull it back down. And it had gotten stuck in the on position. So that transmitter was completely off, no red lights, no nothing, and yet there was still high voltage in that transmitter. Right after that, we had to pull that relay off the wall and take it to a GE service center and have them go through it.
Wasn't it one of there was a company built in AM years ago where if you shut it down and got the output disconnected fast enough, and it didn't have to be really, really quickly, that there was still power on the control circuitry bleeding off, and the SWR protection would detect the open circuit and immediately try to reduce power by bringing the transmitter up at reduced power after you'd turned it off. So again, trust but verify. The other one that reminded me of a story, well, not a story so much, but at least once a year I'll read about somebody having a close experience because a bleeder resistor was blown and didn't discharge the HV. So yeah, it's not paranoid if they really are out to get you. So, and David makes another good comment too, but remembering to take off like anything conductive, wedding rings. I'm not wearing my watch at the moment for that reason, but yeah, exactly. Good point.
Remember to take off your wedding ring despite what your wife says.
Yeah. Or now here's a cool thing. So you can get non-conductive, like almost rubber band type wedding bands now. And I've run into a few engineers that wear those. The two advantages: number one, when you jerk your hand back from the thing that zapped you, you don't end up getting the ring caught in something and shearing all the skin off your finger in the process too, because they've got some stretch. So yeah, it's not just the electrical, but the physical damage you can cause. There, Michael mentions had a pinhole burned in my finger from an open coax connected to an FM antenna, and that's another good one. Loose coax connections. I ran into a 50 kilowatt AM once that only had one bolt on a 3 1/8 inch flange, and that was only finger tight. So yeah, there's some really, really scary stuff out there. And on that note, I am pretty much done. I have to wrap up and get on to the next big thing.
Coax off sample lines will get you too.
Yep. Good point, Brian.
Well, Jeff, thank you again. We appreciate you taking the time as always, and look forward to another opportunity to pick your brain.
My pleasure. Oh, one last thing. Tim mentioned in the chat that he learned the hard way that everything at a AM site is hot. And depending on grounding, that very much can be the case, right from the chain link fence to the front door to anything that's made of conductive material. So, yep, again, care and caution and EH rated footwear. All right. Thanks, Barry. I appreciate it. I'll let you go now.
Thanks, Jeff. See you soon.
All right. See you, everybody.